Hi, welcome to another video on math problem solving. My name is Bharat Divyang from Linswang Academy. Today is National Math Day, so wishing all the math students across the world and the ones who are watching these videos a very happy National Math Day. So I have a very interesting problem that we can try and solve today. But before that, there are a couple of resources that I want to share which should be interesting. So the first one is there's a curated list in short form about the 100 best math books, and you should check it out. So Godel Escher Back was one of the first books. I mean, really interesting books that I read in college. Very, very tough read, but fantastic. It really opens up your mind. A couple of other books that I've read, but not all of them. So even I'm very keen to kind of explore this. Another nice article that caught my eye today was top 10 famous Indian mathematician. The website is a little ad heavy, please ignore that, but otherwise I think it's a good read, especially even if you can't read all of it. Getting to know a couple of names is very interesting. One thing I would like you to look at is Kapreker, because there's a number that's named after him, a Kapreker constant 6174, and it's something that's very interesting that you should check out about why that is the case. Another one, which is not probably like the last in priority, is how art and math is connected, and you should definitely check it out. You'd have heard about it, especially if you've read books like Da Vinci Code. You'd have heard about the golden ratio and how paintings like Mona Lisa or Vitruvian Man follow these golden ratio, and it's a good read. You should definitely check it out. So I hope I thought I'll bring this to your attention before we go to today's problem. So what is today's problem? So this is a king. A king is a piece in chess which can basically move, attack, and control diagonally or vertically or horizontally. In other words, 8 squares around it. It can either control, it can move, or it can capture any piece that is there. So this is a king in the game of chess. Now, when two kings are placed next to each other, the rules of chess prohibit them from coming right next to each other. Therefore, these 3 squares is what I call as no king's land. So neither the black king nor the white king can come there, neither the black king nor the white king can capture that, and in fact both of them control it. But it's of no use. So that's the no king's land. So this is a pattern in chess. The question for today is how many different arrangements exist in a 3 by 3 square where both kings can be placed, still following the rules of chess, which means that they won't capture each other. How many different ways can we do this? This is the first part of the problem, which I will solve and open it up for you to try and solve the other one. The second part of the problem is to extend the same thing and say, okay, how many different ways can I arrange in a 4 by 4 grid? All right, so let's begin with the 3 by 3 grid. So the best way to solve this problem for the 3 by 3 grid is to understand the difference between the squares in terms of their position. So this is the center, and these 4 would be the corners, and these 4 would be the edges. And given the symmetry of the 3 by 3, all you have to do is figure out if the king is placed in a corner, how many arrangements exist. Multiply that by 4 because there are 4 corners. So you think of it as corners, edges, and center. You look at the number of possible arrangements and you look at the total number of corners, edges, and centers, and this would be probably the number of arrangements. So the number of corners is 4, the number of edges is 4, number of centers 2. So what possible arrangements exist? So let me do it for an edge. So this edge ensures that all of this is the no king's land. So you can't have the white king anywhere here. But it can be any other place, which means 1, 2, 3. So there are 3 arrangements when the black king is on the edge. And therefore, the total number of arrangements where black king is on the edge and the white king is somewhere else is going to be 12. You can pause the video and try to do the same thing for the corner. What is the possible ways in which the black king, if the black king is in the corner, white king, where can the white king be? Okay, and the answer is 5 possible ways, and therefore the total number of arrangement is 20. The center, interestingly, creates 8 no kings land, so there's no way that the white king can be in any one of those, so it is 0. So in total, the answer is 32. Now, you might say, okay, this is not really mad, there's a lot of chess. Actually, that's not true, because this question appeared in an American mathematical contest in 2024. So there's a lot of relationship between math and pretty much everything, definitely in chess. So now let's extend this a little bit and ask this question. What about a 4x4? How many possible arrangements exist for a 4x4? So pause the video here, try and solve it, go through the productive struggle, try to figure out if you are able to arrive at the answer. Okay, welcome back. Now let's try and solve this problem. So it's a 4x4. I hope you went through the productive struggle of actually going through and trying to solve this problem. So if it's a 4x4, the first step is to understand that there's going to be corners, there's going to be edges, and there's going to be centers. So the defining factor for the corner is that it has 1, 2, 3 no kings land. So let's list it down, okay? So first we'll count the number of corners. So the number of corners is 4. The number of edges would be 8. Number of centers would be 4. In total, it needs to add up to 16. That makes sense. What's the redeeming factor? Why are all 4 corners blocked together? What's the similarity between the 4 corners? And that's the number of no king squares. So for the corner, it is 1, 2, and 3. So there are 3 no kings. And when the king is on the edge, there are 5 no kings. And when the king is in the center, there are 8 no kings. And therefore, you can think of the number of available squares for the white king when the black king is placed in the corner is going to be 16 minus 3 minus 1, because the king is also there, so it's minus 4. So in other words, there are 12 possible places. Can we just check that? Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12. Now think of the edge. So you have 5 of them, which means 16 minus 6, 10 is going to be the number of available squares. So you can think of it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's correct. So for the center, you would have 8 no king's land, giving you the last layer. 5, 6, 7. Right? So it's 16 minus 9, giving you 7. So this is the total number of available squares. So the answer, the total number of arrangements, is going to be a product of these two. So 4 times 12 is 48, 8 times 10 is 80, and 4 times 7 is 28. So adding up all of this, you get 80 plus 40. You can do it in a simple way. This is nothing but 50 minus 2, and this is nothing but 30 minus 2. And 50 plus 30 is 80, 80 plus 80 is 160, which means 160 minus 4 is 156. 160 minus 4 is 1. This is the number. Now we can do without the negatives also. So 80 plus 40 plus 20 is 140, plus 18 is 156. So from 32, it moves to 156 possible arrangements. You can extend this further and ask yourself, hey, if this were a 5 by 5, how would my answer change? And going through this process, trying to answer that question is what's going to make you good at math. It's tough, it's not easy. Your brain will throw in a lot of resistance and say, why do I want to solve this problem? If you've gotten the pattern, you should push yourself to go to the next level of complexity and see that you're able to solve it as well, because that's when the process of solving gets really, crystallized in your mind. I hope you found this video interesting and insightful. If so, please do like, share, and subscribe, and I'll see you in the next video. Thank you.